We have seen the resource grid. PDSCH modulation symbols have already been placed into their allocated resource elements. But once these symbols travel through the wireless channel, they no longer arrive exactly as they were transmitted. Their amplitudes may change, their phases rotate, and noise further distorts them. If the receiver does not know how the channel changed the transmitted symbols, it cannot correctly recover the original information. To solve this problem, network inserts a few special symbols whose values are already known to both the transmitter and the receiver. These special symbols are the key to channel estimation. We call them as Demodulation Reference Signals, or simply called as DMRS. Suppose the transmitter sends a symbol whose value is already known to both the transmitter and the receiver. After traveling through the wireless channel, the symbol no longer appears at the same location. Its amplitude and phase have changed. Since the receiver already knows where the symbol should have been, it simply compares the expected location with the received location. The difference directly reveals the effect of the wireless channel. This is exactly the role of DMRS. Along with the PDSCH data symbols, transmitter also inserts a few special symbols called DMRS. Unlike the PDSCH symbols, these symbols do not carry any user data. Their values are already known to both the transmitter and the receiver. As the receiver already knows exactly what the symbol should be, it simply compares the received DMRS with the expected sequence. This comparison allows the receiver to estimate the wireless channel. The first few OFDM symbols usually carry the control information, which is PDCCH, and the remaining symbols are used for scheduling PDSCH transmission. DMRS does not occupy a separate channel. Instead, a few resource elements inside the PDSCH allocation are reserved for DMRS. Both the transmitter and receiver know exactly where these DMRS resource elements are located, and the remaining resource elements continue carrying normal PDSCH data. DMRS and PDSCH are transmitted together. They are multiplexed inside the same resource grid. Some resource elements carry user data, while a few carry DMRS symbols. Receiver first extracts the DMRS resource elements and feeds them into the channel estimator. Using this channel estimate, receiver equalizes the surrounding PDSCH symbols before decoding the transmitted data. Suppose only one DMRS symbol were transmitted. Receiver would know the channel only at that single location, leaving the remaining resource elements unknown. Instead, DMRS symbols are inserted at multiple locations across both time and frequency, providing many reference points. Then the receiver combines these reference points to estimate the complete wireless channel. This estimate is then used to equalize every surrounding PDSCH symbol. Without DMRS, receiver does not know how the wireless channel has distorted the transmitted symbols. By using DMRS, receiver estimates the channel, equalizes the received symbols, and recovers the original constellation before decoding. This is why DMRS is essential for every PDSCH transmission. Our resource grid is now almost complete. Many resource elements carry PDSCH data. Some resource elements carry DMRS. Together, they form the complete PDSCH transmission. Now every resource element has a purpose. Some carry data, while others carry reference signals. But one important question still remains. How are all these resource elements converted into the continuous waveform transmitted over the air? The transmission happens through OFDM modulation. Let's summarize what we have learned. After precoding, every modulation symbol is mapped into its assigned resource element. DMRS symbols are then inserted alongside the PDSCH. Together, they form the complete resource grid that is ready for transmission. The only remaining step is to transform this frequency domain resource grid into the time domain waveform that leaves the antenna. The transformation is performed using OFDM modulation, which we will explore in the coming episodes.